Assalamualaikum warahmatullahi wabarakatuh to our lecture QMT342. Whether Ismailiana Binti Ismail. We from CS1115C and we are from group number 1. We will present to you our finding for queuing theory project. For our group project, we choose TF value mart for our observation. Before we choose our finding in queuing theory project, I would like to introduce you to my group members. There are 4 group members including me. My name is Siti Aisyah binti Mohammad Sazaley, Mohammad Alif bin Anas, Ainun Afiqah binti Ahmad Safian, and Norliyana Haziyah binti Haizul Azwan. For the introduction, to our observation place, which is TF Value Mart, is located at number 91, Jalan Balduin 3, Pusat Perniagaan Balduin in Tapah Perak. For the operating time is 10 AM until 10 PM. The number of servers is 6 servers. And for our observation time is 5 PM until 6 PM, which is at the peak hours.
The next one, we will talk about the arrival characteristic. The first one, size of the coin population. The shopper or the customer will arrive at the TF at any time and in the business hour. And the next one, we have the pattern of arrival at the system. With the portion distribution, we observe that there is 125 customers per hour. And the last one, the behavior of the arrival exists. The customer type is the patient customer. They are willing to wait in the queue to get the service at the cashier counter.
For the next topic is the waiting line characteristic. So for the first one is the length of a line. The length of TF Verima is actually unlimited. The store need to provide the service to their customer within their business hour. So the next one is the queue discipline. So the queue discipline for TF Value Mart is first in, first out. So any customer that first come to the counter can make the payment and can go with their days.
For the next one, we talk about the service facility characteristic. We observe there is 11 server at TF, but they only open seat at the one time. For the arrangement of the server, we found that they are using multi-channel and single-phase system, which means the server, they have a lot of server, and the customer only need go through the service facility once. That means the customer will go and get the grocery and pay at the cashier counter, which is the service facility. And then after the payment is done, they go out from the system. And the next one, we will talk about the number of waiting line. We found that there is 6 line because the server only opens 6 at the one time. And the last one, the pattern of the service time, followed by the exponential distribution. We found that the customer service time is 25 customer per hour.
I am Nana, so I will be assist you with the results of queuing model. So first we look into the utilization factors. This is the formula. We use rho equal to lambda divided by S times with mu. So lambda here is the average number of arrivals per time period, while S is the number of servers, and the mu is the average number of people served per time period. For rho, we will get the value of 0.8333. Next, we go to the probability that there are 0 customers in the system. So here, probability is P naught. So we use this formula and then we will obtain the value of P naught, which is 0.004513. So next is the average number of customers in the queue. We use this formula, which is LQ equal to rho times with lambda divided by mu with the power of S value times with P naught, and divided by x factorial times with 1 minus rho with the power of 2. Then we will obtain the value of 2.9368 and approximately equal to 3 customers. So here we need to get the whole number because here we want to get the average number of customers in the queue. Next, we need to get the L. L is the average number of customers or units in the system. So we use this formula which is L equal to LQ plus with lambda divided by mu, and then we will obtain the value of 7.9368 and approximately equal to 8 customers. So here also we need to get the whole number because we want the average number of customers in the system. Next, we need to get the value of W. So W is the average time a customer spends in the system. We use this formula which is W equal to L over lambda, and then we obtain the value of 0.0636 hours. So here we need to get in the minutes, so we will times with 60 minutes and then we will get the 3.81 minutes. After that, we need to get the LQ value, which is LQ stands for the average time a customer spends waiting in the queue. So the formula for the WQ is equal to LQ divided by lambda, and then we will get the value of 0.025 hours. We need to get the value in minutes, so we need to times with 60 minutes and then we will get 1.41 minutes for the average time a customer spends waiting in the queue.
Okay, so for the last part is the conclusion part. Okay, we actually have three questions in this part. So the first question is, the number of servers provided adequate? Yes, obviously, one factor contributing to quick service in a system is the number of open servers. Having more servers reduces customer wait times and improve overall service. The second question is, the customer happy with the waiting time? Yeah, of course. It is because the average time the customer spends waiting in the queue is just around a minute. And the last question is, describe what we have learned from the project. So we learned from this project that the mu times lambda value needs to be bigger than the lambda value. With this, the system can handle more customer efficiently and the customer doesn't have to wait for a long time.
So here is the output that we have run from the QM for Windows. As you can see, the LQ, L, WQ and W value is same with the value that we have calculated manually.
That's all from us. Thank you.